I learned in those days at Yanfeng that the ClickRim technology saves 2/3 of production sites through automated wrapping. How much of your innovation budget goes actually into improving and innovating the manufacturing processes instead of innovating the features?
That very much depends on the product mix that we have. So sometimes we have products where we have to focus on the features, on the end consumer value. Sometimes we have to focus on the manufacturing side. So effectively, the needs of the business drive what the mix is. So sometimes we have more product innovation, sometimes we have more manufacturing process innovation. It just depends. Important is that we contribute to all factors, as I mentioned before, features, product, and processes. I think it should always be a healthy mix over the time that we work on innovations. And I mean, at the end, it all comes together anyway, because we have something that we call the smart cabin approach, where we look at the ambience, where we look at multimodal operation, where we look at integrated safety, where we look at connected services. So that's all something where things come together anyway. So it's sometimes actually really difficult to say, is it in product innovation, is it manufacturing innovation? Because most of the times it's a combination of both.
And I know also that you're responsible for particularly innovation for the European market. Can you give me some examples and also tell me what is so unique about that?
And maybe to start, the answer is that most of the innovations, if not all, are always catered to a global application. So even though we may have certain needs in the business of our customers, of our organization, it could mean that we have to tailor that to a very specific need. Typically, the setup is always that it's a global innovation. Mm-hmm. And a couple of examples, I mean, we talked about ClickRim, which is something that came out of our European team, which is actually a fairly neat innovation that most likely will also apply globally. Mm-hmm. We have technologies like, let me just show you. One technology that we've developed here in Europe, actually for a global application, but it was very much driven by a need in one of our European plants. It's called in-mold heating. It's basically where we integrate a heating mat in the injection molding technology, in the injection molding process, and with that create a panel that has a hard injection molded component, but that also has an integrated heating mat. Mm-hmm. The cool thing about that is the challenge that we had in the past is that you always had to have a manual lamination operation for the heating mat, which you can eliminate with that process. And also we have an integrated plug, which deletes the chances that you have on a normal part where you have loose cables and you have to attach and install those loose cables. So that's a source for errors in the production process. So that's eliminated because now we have a plug-and-play process. So it sounds like a very easy thing, but it's quite challenging to get that worked out in the production process. But that's something that really provides a unique advantage. Also, it provides an advantage because the heating is very close to the end consumer. So it has, again, as I said before, it has advantages from the manufacturing side, but it's also a neat product innovation that contributes to more comfort for the end consumer. Mm-hmm. So that's actually quite cool. Maybe as a second technology, direct backfoaming, same thing. I mean, we always were looking at how can we provide soft surfaces with a wide variety of surface technologies to the customer. So this is, for example, a fabric surface. We also have that as foils. We also have that with other technologies. And the cool thing about that is that we laminate the surface to a PP panel. Mm-hmm. That again gets put into the tool and then it gets foamed together and it creates the instrument panel surface. Of course, that's only just a cut off of it. Normally, you need to have a specific tool for each of the materials that you cover the instrument panel with. So that's relatively costly. If you say you have an instrument panel with leather, an instrument panel with textile, and an instrument panel with a plastic foil, you need to have 3 different tools. With that technology, because we laminate before the surface to a PP panel and put that into the tool, we can do all of these variants with one tool. And again, it provides some unique advantages for the end consumer because you have some really cool craftsmanship, but it also is like a neat manufacturing improvement that can be commercialized globally.